Have a nice day to you all. Today we are going to discuss exponential smoothing techniques. We can use some synonyms for these terms. Then let's see first what in the slide. One of the most successful forecasting methods in exponential smoothing. Exponential smoothing is an averaging technique that uses unequal weights and signs exponential decrease in weights as the observation get older. There are several exponential smoothing techniques. One is single exponential smoothing technique, then Holt's linear method, then we can call it as a double exponential smoothing technique either, because those two are synonyms. Then Holt Winter's trend and seasonal method, we can call it as a triple exponential smoothing method, because I think in the single exponential smoothing method, we are using only a single weight. In the Holt's linear method, we use two things. Then other than the thing we considered on the first step, we are adding the trend into the model. So we consider the linear trend also in that step. So in the third step, rather than the first two, we are considering the seasonality also there. So we called it as a triple exponential smoothing technique, either as a synonym for this third name. Yeah, the single exponential smoothing, the method of single exponential forecasting takes the forecast for the previous period and adjust it using the forecast error. So we use forecast error here, and we need to decide some values for the alpha. Then we can use values from 0 to 0.9 for that alpha. Then we can select what is the best alpha value using our error measures. Most probably we are using mean absolute percentage error, the minimum value, the model with minimum mean absolute percentage error. In short form, we call it as MAPE. The model with minimum MAPE we use as the best model. So these two equations are same because we can use then the first one is a simplified method of the second one. So those two are equal. So these notations are also, you can read, YT is actual value, FT is forecasted value. Alpha is weighting factor, which ranges from 0 to 1. T is the current time period. So we can estimate these things in this way. And this one is easily, we can calculate manually. But other two parts are cannot do using some values manually. We have to use some computer softwares to do that part. Choosing the best value for parameter alpha. In practice, the smoothing parameter is often chosen by a grid search of the parameter space. That is, different solution for 0.1 to are tried starting with 0.9 with increment of 0.1. Then we can start our calculations from 0.1 and we can increase it by 0.1 point up to 0.9. So after completing this all, we can estimate the MAPE and select the best model. Then is chosen so as to produce the smallest sum of the square of the residual. So that's the thing I stated earlier. Yeah, there are some values. So these are some examples. Then you can use this alpha 0.1, 5, and 9 for the equations we discussed here, and you can check whether these values are coming or not. The thing is, this is the current period 1. For the next period, we use the first observations in here as the estimated value, because to estimate these equations, we should have one forecast fitted value and the forecasted value. So we can use the first observation here as a forecast value just to start the calculation. So that's an application when you should keep it in your mind. Okay, these are the estimated error values. Then you can cross check by completing those calculations manually, and you can check whether these values are coming or not. Then under the MAPE, mean absolute percentage error. This is the minimum one. The minimum MAP is for the alpha equals 0.1. So you can select the alpha equals 0.1 as the best value. Yeah, then you can plot those things. And here it has considered about the Holt's linear method. Then Holt extended single exponential smoothing to linear exponential smoothing to allow forecasting of data with trends. The forecast for Holt's linear exponential smoothing is found using two smoothing constants, alpha and beta. Rather than the alpha we considered in the first stage. Here we are considering beta also as a slope, as a trend. So these are the steps of calculating. Finally, we can use these equations to make our forecast. So separately, we should estimate the LT and we need to estimate the BT. So this is somewhat harder to manually calculation. So we can use as a statistical software to do these calculations. And the third step, Holt's winter trend and seasonality method. Holt's method was extended by Winters in 1960 to capture seasonality. So Holt Winters method is based on three smoothing equations, one for level, one for trend, one for seasonality. So you can see this is for the level, this is for the trend, this is for season. So this forecasting technique has captured more details. So now you can remember what are the smoothing techniques you have learned. Then you will realize this is the best method, captured more information about the series to make a good forecasting. So as well as we can use this kind of a technique, especially for the data series which has seasonal effects, because here it has considered the seasonality, so it will be more effective rather than the other techniques. So it's a graphical interpretation of the estimations. So now you can realize what are the exponential smoothing techniques. Now I'm going to show you how to conduct this test using Minitab. So here I have opened a variable, time series variable. So that's the observations of my time series variable. I have used official tourist receipts. To Sri Lanka from 1971 to 2019. So that's my data set, time series variable. So now I'm going to make a exponential smoothing forecast for my variable. So you can follow the tab stat. Under that you can select time series. Then you will have more options about time series analysis. So you can select moving averages also. Then here you can see the three steps we discussed under the exponential smoothing: single exponential smoothing, double exponential smoothing, and Winters method. So I have expressed you some synonyms also for these techniques. So now you can easily capture what mean by these things. Anyway, as the first step, I'm gonna select single exponential smoothing. Okay, now there's a new window. So we can select our variable. So my observations are available under the C1. So C1 is here. Now I can select my variable, and then suppose if you have more variable in your data set, you can select what is the variable you need, because after you completing some variables in your worksheet, that may be visible in here. So still I have only one variable, so only C1, then the column name is C1. Now column C1 is visible here. Okay, now after clicking, after double click on that one, you can take the variable into this space in front of the variable. Then that is the weight of using smoothing, that will take some weights automatically. Then if you need to give some values, you can use this use. Then you can give some values. Then you can start it with 0.1 and you can put some other values also. Anyway, I am giving the options to take it automatically by the system. Okay, then I'm going to make OK. This is the estimated one. There is a smoothing, a single exponential method, a smoothing plot for C1. Then you can see the actual values are from the black dot and black line, and fitted values are visible in here with the square and the red broken line. Now the selected smoothing constant alpha, they have considered as 1.92, and these are the MAPE values. So you can take the values in here. Okay, then something is misleading here, then they have taken alpha as 1.92, but we discussed we can take values from 0 to 0.9, then we can check. Yeah, this is the graph for the 0.1, then that is somewhat far away from the actual behavior. Then I will change my value into 0.9. Yeah, when we use 0.9, it is somewhat approximate to the actual value rather than the 0.1. But anyway, theoretically, this is the maximum applicable one. But anyway, the system has selected it as the 1.9, but it is somewhat abused thing. So as the student who engage with the subject, you should know what are the applicable things. Now I'm going to estimate the double exponential smoothing. Then what is the path, as we stated very early? You can follow stat ribbon and find this option. Under that, you can select double exponential smoothing. Then that is for an alternative name for the Holt's exponential method. So we can select that one. Okay, then I think you can see we should give values for the level as well as trend. So if you use the optimal arima, you can have some automatical values, and otherwise you can give some values for these things. Suppose I am going to give 0.1 for the both trend and level as my first option. Okay, this is the estimated thing. Then the black one is the actual one. So the red line is the smooth value under the double exponential smoothing method by considering alpha and gamma value for those two exponential values. Now I'm going to change those things. I'm going to give, you can check these things by giving some separate answers. Now I'm going to give 0.9 for both. Now it is somewhat totally on the actual one. So if we check the MAP is 610.0. Let's check what will give by the system. If we given the options to take that maximum opportunity by the system, they are taking the best value among the estimated value, all options. Okay, they are taking these things as these values, and they have used the gamma as 6 point something. But anyway, it doesn't matter. Alpha is 0.17. It is applicable under our conditions. So the MAP is also somewhat low because the last time which I estimated it was 110.2. And now it is 37.2. Okay. Now you can realize how to estimate double exponential smoothing. Let's see about the triple exponential smoothing. Otherwise, we can call it as the Winter's method. Okay, now you can see there are three options to give some weights for the seasonal, trend, and level. Then we can select whether our model is additive or multiplicative. Then we can click on OK. Okay, I couldn't select my variable. That was the error. I gave my variable. Then seasonal length also I should give. But here actually these are annual data, so I'm ignoring that part. Yes. Let's give some test one. Then this is annual data set, so the seasonality not available under this one. So as I stated you earlier, we cannot estimate seasonality for annual data. So just an example, I give 4 as the quarter, so that has been estimated under that one, but it is a non-application. So you need to keep it in your mind to give a proper thing. Okay. If I select the multiplicative option, that is also in this way. Okay. I think now you know how to estimate exponential smoothing techniques. So I think this is enough for the topic.